Hello, I'm Ryan Rice from the Washington State University Department of Chemistry, and in this video I'm going to cover the molar mass of an unknown acid post-lab. The first post-lab question asks you to perform the calculations necessary to determine the concentration of the sodium hydroxide solution you used. We covered how to do this in the previous video on the molar mass of a known acid. If you need to review it, click the link that appears on your screen. Post-lab question 3 asks you to perform the calculations needed to determine the equivalent molar mass of your unknown acid. These calculations are similar to the ones you perform for the molar mass of the known acid, but with the added twist that since you don't know the acid's reaction stoichiometry with sodium hydroxide, for now you will have to assume they react in a 1-to-1 ratio. Our first task is to calculate the number of moles of sodium hydroxide we use to titrate our unknown acid solution. For this example, let's assume it took 16.50 milliliters, and this number comes from our burette data, yours might be different, 16.50 milliliters of a 2.460 molar sodium hydroxide solution to complete the titration. First, we convert 16.50 milliliters into liters, and that's what I've done right here. So that's 0.01650 liters sodium hydroxide. And then we multiply this volume by the sodium hydroxide solution's concentration of 2.460 moles per liter. Liters cancel, and we have 0.04059 moles of sodium hydroxide. Now we must use the reaction stoichiometry to convert these moles of sodium hydroxide into moles of unknown acid. Again, since we don't know what ratio these two actually react in, we're going to assume it's 1-to-1. Applying this stoichiometry, 0.04059 moles of sodium hydroxide times the ratio of 1 mole of unknown acid, which I'm just going to abbreviate here as HA, over 1 mole of sodium hydroxide. Sodium hydroxide cancels, and we have 0.04059 moles of unknown acid. Now that we know how many moles of unknown acid were titrated, we can calculate the concentration of their solution by dividing moles by volume, where the volume in this case is equal to that of our volumetric pipette. For this example, we had 0.04059 moles of unknown acid, and if our pipette volume was 15 milliliters, then we divide this number of moles by 0.01500 liters. And this gives us a concentration of 2.706 molar unknown acid. Our next step is to calculate the total number of moles of unknown acid we use to make our unknown solution. For this, we take the acid solution's concentration, 2.706 moles of unknown acid per liter, and we multiply by the volume we use to cancel liters. The volume in this case is equal to that of the volumetric flask we made our solution in. If we used a 200 ml volumetric flask, then we would multiply 2.706 moles of unknown acid per liter by 0.2000 liters. Liters cancel, and we have 0.5412 moles of unknown acid. Now that we know the total moles of unknown acid that were in the solution we made, we can take the number of grams we used to make it with and use those grams to calculate the acid's equivalent molar mass. If we used 51.07 grams of unknown acid, and this number comes from your weigh bottle mass data, then to find the molar mass of the acid, we divide 51.07 grams by the number of moles, in this case 0.5412 moles. In this case, we get 94.36 grams per mole. In your own post-lab assignment, you'll do this series of calculations 3 times using data from your 3 careful titrations in turn. You will then average your 3 molar masses and calculate their standard deviation in post-lab question 4. Post-lab question 5 asks you to calculate the range your standard deviation falls around your average. To do this, you take the average and add and subtract 1 standard deviation from it. If, for instance, our average was 94.68 grams per mole and our standard deviation was 1.56 grams per mole, then the range would be for the low end of the range, it would be our average minus 1 standard deviation, or 93.12 grams per mole. And the high end of the range would be the average plus 1 standard deviation, or 96.24 grams per mole. We're going to skip a bit to discussion question 2, which asks us to determine the most likely identity of our unknown acid. In order to answer this, we first have to determine what our unknown acid's molar mass would be if it were monoprotic, diprotic, or triprotic. To get these numbers, all we have to do is multiply the average molar mass we calculated earlier by 1, 2, and 3 respectively. If, for example, our acid were monoprotic with 1 proton per acid molecule, its actual molar mass would be 94.68 grams per mole times 1, or just 94.68 grams per mole. If, however, it were diprotic with 2 protons per acid molecule, its molar mass would be 94.68 grams per mole times 2, or 189.4 grams per mole. And if it were triprotic with 3 protons, its molar mass would be 94.68 grams per mole times 3, or 284.0 grams per mole. At last, we come to the part where we use the numbers we've calculated to identify the unknown acid. To do this, you take the 3 molar masses you get if your acid were monoprotic, diprotic, or triprotic, compare them to the list of possible unknowns you were given in lab, and see what gives you the best match, accounting for both the molar mass of each as well as how many ionizable protons it has. Let's say, for instance, that the list from lab contained the following 4 acids and their molar masses. Numerically, the closest match we have here is between acid C's molar mass of 189.47 grams per mole and our calculated molar mass of 189.4 grams per mole. However, since acid C is known to be triprotic, whilst our unknown's molar mass only calculates as 189.4 if we assume it's diprotic, our unknown probably isn't acid C. The next best match is, once again, 189.4 to acid H's 193.65. Acid H is also diprotic, and at 189.4 grams per mole, we're assuming our unknown is diprotic as well. Therefore, our unknown acid is most likely acid H. Discussion question 3 asks you how the molar mass of a known acid experiment was relevant to this one. When you go to answer this, think about what that previous experiment had to say about your technique's accuracy and what the implications are for this experiment. So that's the molar mass of an unknown acid post-lab. I hope this information was helpful. Once again, I'm Ryan Rice from the Washington State University Department of Chemistry, and thank you for watching.